Aerojet was an American rocket and missile propulsion manufacturer based primarily in Rancho Cordova, California, with divisions in Redmond, Washington, Orange and Gainesville in Virginia, and Camden, Arkansas. Aerojet was owned by GenCorp. In 2013, Aerojet was merged by GenCorp with the former Pratt & Whitney Rocketdyne to form Aerojet Rocketdyne. History: Aerojet developed from a 1936 meeting hosted by Theodore von Karman at his home. Joining von Karman, who was at the time director of Guggenheim Aeronautical Laboratory at the California Institute of Technology, were a number of Caltech professors and students, including rocket scientist and astrophysicist Fritz Zwicky and explosives expert Jack Parsons, all of whom were interested in the topic of space flight. The group continued to meet from time to time, but its activities were limited to discussions as opposed to experimentation. In 1938, the United States Army offered two research projects, one for aircraft windshield de-icing and another for rocket engines to launch aircraft. Their first design was tested on August 16, 1941, consisting of a small cylindrical solid-fuel motor attached to the bottom of a plane. Takeoff distance was shortened by half, and the USAAF placed an order for experimental production versions. On March 19, 1942, the company was officially formed in Azusa, CA, known as Aerojet Engineering Corporation. The founders were Frank Molina, von Karman, Parsons, Edward S. Foreman, Martin Summerfield, and Andrew Haley. In 1943, the Army Air Forces finally placed a full order, demanding that 2,000 be delivered before year's end. The company also invested in pure rocket research, developing both a liquid fuel design and a new solid fuel design based on a rubber binding agent in partnership with General Tire. In the immediate post-war era, Aerojet downsized dramatically, but their JATO units continued to sell for commercial aircraft operating in hot and high conditions. By 1950, their research into the rubber binder had led to much larger engines and then to the development of the Aerobee-sounding rocket. Aerobee was the first U.S.-designed rocket to reach space and completed over 1,000 flights before it was retired in 1985. Aerojet designed and built a total of 1,182 engines for all four incarnations of the Titan rockets, which were used for civilian projects ranging from Gemini's manned flights to solar system explorations including Viking, Voyager, and Cassini. The newly formed U.S. Air Force used Aerojet as the primary supplier on a number of their ICBM projects, including the Titan and Minuteman missiles. They also delivered propulsion systems for the U.S. Navy's submarine-launched Polaris missile. A new plant was set up in Sacramento that took over most rocket construction, while the original Azusa officers returned primarily to research. One of Azusa's major projects was the development of the infrared detectors for the Defense Support Program satellites, used to detect ICBM launches from space. The new research arm was formed as Aerojet Electrosystems Corp., and after purchasing a number of ordnance companies, Aerojet Ordnance was created as well. A new umbrella organization oversaw the three major divisions. Aerojet General. President Kennedy's challenge to place a man on the moon by the end of the 1960s led to increased civilian work at Aerojet. Previously, they had repeatedly lost contracts for large engines for the Saturn and Nova boosters, being designed in the late 1950s, often to their rival Rocketdyne, but in the end were selected to develop and build the main engine for the Apollo Command Service Module. In 1962 they were also selected to design a new upper stage engine to replace the cluster of 5 J2S used on the Saturn second stage and the post-Apollo era, but work on their resulting M1 design was ended in 1965 when it became clear the public's support for a massive space program was waning. Similar work continued in the 1970s, delivering the second stage motor for the MX missile, the orbital maneuvering system for the Space Shuttle, and the first U.S.-designed cluster bombs. A contract for 30 mm ammunition for the A-10 Thunderbolt II was so extensive that new branch plants were set up in Downey and Chino in 1978. Aerojet also purchased a number of other firms over this period, and their plant in Jonesboro, TN developed the use of depleted uranium ordnance. To this day they are the primary supplier of these weapons. Their electronics and ordnance divisions also collaborated on the SADARM-8 anti-armor artillery round, but this was never put into production. The 1980s saw a brief revival of the aerospace business during President Reagan's Strategic Defense Initiative program, but the company shrank during the late 1980s and into the 1990s. As Aerojet downsized, many of their industrial plants were idled, and the company looked for ways to capitalize them. Their massive investment in chemical mixing equipment used to build their solid-fuel rockets was later leased to third parties, notably pharmaceutical companies, under the name Aerojet Fine Chemicals. The division was later sold. Aerojet Real Estate was more direct in its actions, leasing entire Aerojet buildings and selling off undeveloped Aerojet land. It owned approximately 12,600 acres, located 15 miles east of downtown Sacramento. The remaining research and development sections of Aerojet were organized into the Aerospace and Defense Division. They continued to develop and produce liquid fuel, solid fuel, and air-breathing engines for strategic and tactical missiles, precision strike missiles, and interceptors required for missile defense. Product applications for defense systems included strategic and tactical missile motors, maneuvering propulsion systems, attitude control systems, and warhead assemblies used in precision weapon systems and missile defense, as well as airframe structures required on the F-22 Raptor aircraft and fire suppression systems for military and commercial vehicles. Their space-related products included liquid fuel engines for expendable and reusable launch vehicles, upper stage engines, satellite propulsion, large solid boosters, and integrated propulsion subsystems. Aerojet qualified a 4.5-kW Hall-effect thruster electric propulsion system based on technology licensed from the Busek Corporation. Aerojet is under contract to Lockheed Martin to provide the first two ship sets of the new thruster system for the next generation Advanced Extremely High-Frequency System, a U.S. Air Force program. Research into the next generation of advanced or green monopropellant engines met with mixed success in the 1990s. Han engines developed under contract to the U.S. Air Force and Missile Defense Agency provided proof of concept. Recent history: Aerojet is currently owned by GenCorp, which is headquartered in Rancho Cordova, California. GenCorp was known as the General Tire and Rubber Company until 1984. From 2002, Aerojet grew steadily to more than 3,500 employees in 2008. Aerojet's rocket engine for the Delta II second stage completed a record 268 successful mission launches on February 6, 2009. Since 1960, NASA chose Aerojet to provide the primary design and development of Orion spacecraft propulsion systems for the Constellation program. In November 2010, Aerojet was selected by NASA for consideration for potential contract awards for heavy lift launch vehicle system concepts and propulsion technologies. In July 2012, GenCorp announced that it was buying Aerojet's competitor, Pratt & Whitney Rocketdyne. The acquisition was completed in 2013. Florida facility and canal. Aerojet solid fuel technology was under consideration for use in Apollo's Saturn V first stages. In 1963, the U.S. Air Force provided Aerojet General with $3 million in funding to start construction of a manufacturing and testing site several miles southwest of Homestead, Florida. Aerojet acquired the land for the plant less than 5 miles from Everglades National Park. A facility was constructed where the motors could be built and tested. SW 232nd Avenue was renamed Aerojet Road. A monolithic, 21-foot diameter rocket motor was designed, which was too big to be transported by rail. A plan was devised where the rocket motors would be transported by barge to Cape Canaveral. To facilitate barges, a canal was dug and a drawbridge installed for the U.S. Highway 1 crossing at mile marker 116. This canal became the southernmost freshwater canal in southeast Florida and was dubbed the Aerojet Canal. A concrete silo was constructed for the rocket motor, 180 feet deep into the Everglades. Aerojet needed a cylindrical chamber that would withstand the force and power a spacefaring rocket would cause. Aerojet subcontracted the fabrication of 260-inch diameter, 24 meters long chamber. The chambers were designed in short length, meaning half the size of what the final product would be, hence the names given to the test rockets. SL-1, SL-2 and SL-3. Both motors used a propellant burning rate and nozzle size appropriate for the full-length design and were capable of about 1,600,000 kilograms force thrust for 114 seconds. The large amount of propellant needed for such a rocket was manufactured at the Everglades plant. An ignition motor, a knockdown Polaris missile B-3 first stage known as blowtorch, was used to jump-start the motor. Between Sept. 25, 1965 and June 17, 1967, 3 static test firings were done. SL-1 was fired at night, and the flame was clearly visible from Miami 50 kilometers away, producing over 3 million pounds of thrust. SL-2 was fired with similar success and relatively uneventful. SL-3, the third and what would be the final test rocket, used a partially submerged nozzle and produced 2,670,000 kilograms force thrust, making it the largest solid-fuel rocket ever. Problems arose during the third test when, near burnout, the rocket nozzle was ejected, causing propellant made of hydrochloric acids to be spread across wetlands in the Everglades and a few crop fields and homes in Homestead. Many residents of Homestead complained about the damage done, which included paint damage to their cars and killing thousands of dollars worth of crops. By 1969, NASA had decided to go with liquid-fueled engines for the Saturn V rockets, causing the workers of the Everglades plant to be laid off and the abandonment of the facility. In 1986, after NASA had awarded the Space Shuttle booster contract to Morton Thiokol of Utah, Aerojet sued the state of Florida, exercised its options and pulled out of South Florida for good. The company sold most of its land holdings to the South Dade Land Corporation for $6 million. After unsuccessfully trying to farm it, the corporation sold it to Florida for $12 million. County and federal courts were kept busy for years with lawsuits between Aerojet, Dade County and the state of Florida. After losing the shuttle contract in 1986, Aerojet later traded its remaining 5,100 acres in the wetlands of South Dade for 55,000 acres of environmentally sensitive land belonging to the U.S. Bureau of Land Management in New Mexico. Those 5,100 acres surrounding the factory site are now controlled by the South Florida Water Management District and the Florida Fish and Wildlife Conservation Commission as a nature preserve. The Aerojet signage still remains for both the road and canal, and although weather damaged, most of the facility's buildings remain intact. The AJ260-2 rocket motor remains in the silo to this day. In 2013, the massive shed structure covering the silo was dismantled and the silo covered with several 33-ton concrete beams. The facility was the subject of documentaries Space Miami and Aerojet Road, An Unfinished Journey. Epa Superfund Sites. Aerojet's manufacture, testing and disposal methods led to toxic contamination of both the land and groundwater in the Rancho Cordova area, leading to the designation of a Superfund site. Solvents such as trichloroethylene and chloroform and rocket fuel byproducts such as N-nitrosodimethylamine and perchlorate were discovered in drinking water wells near Aerojet in 1979. Since then, two state agencies and the Environmental Protection Agency have been working with Aerojet to ensure that the company cleans up pollution caused by its operations at the site. Under state and federal enforcement orders, Aerojet installed several systems on the borders of its property to pump out and treat contaminated groundwater. Aerojet has also conducted a number of removal actions for on-site soils, liquids, and sludges. In 2003, groundwater sampling data revealed a plume of contamination extending northwest under Carmichael. Discovery of TCE contamination at the Sacramento facility also led Aerojet to look into possible contamination of the groundwater at Aerojet's Azusa facility, where much of the testing of JATOs and rocket engines were conducted before moving those operations to Sacramento. In 1980, it was announced that there was TCE contamination in the groundwater at Aerojet's facility in Azusa in a hearing chaired by State Senator Esteban Torres. In 1985, it was declared a Superfund site by the EPA as San Gabriel Superfund Site 2 and the cleanup done under the Baldwin Park Operable Unit. In 1997, it was also discovered that there was also NDMA and ammonium perchlorate contamination in this plume and that Aerojet was once again labeled a potentially responsible party in this action. Aerojet sold this facility in 2001 to Northrop Grumman Corporation. Aerojet's disposal of toxic material occurred 20 years prior to the establishment of a provisional perchlorate RFD limit of 1 × 10⁻⁴ mg per kilogram day in 1992. This limit was increased to 9 × 10⁻⁴ mg per kilogram day in 1998, and prior to the results from NAS studies, the limit was reduced to 4 × 10⁻⁵ mg per kilogram day in 2002. The NAS studies disputed the 4E5 limit, and recommended its current limit of 7 × 10⁻⁴ mg per kilogram day. Products: rockets Aerojet General X-8.